So I'm going to talk to you a little bit today about how to develop students in their ability to develop algorithms. When I was teaching the drag and drop stuff, and I used Scratch BYOB, which is almost identical to what Snap is, we would get to a certain point in the lesson. So it was really easy for me to say, okay, make a program where they can draw a square, and then extend that a little bit. But then when you got to the more advanced stuff, to where I'm like, okay, create this list, and from this list, let's go through the list and add up all the even numbers, they kind of ground to an algorithmic halt. And the kids would get frustrated, and then they wouldn't want to do anything. And so I kind of took a step back and said, well, maybe we just need to develop some of these ordering logic skills and thinking skills and work through a thought process. And so what I found to do that with is a platform called Jeroo. So you can go to www.jeroo.org and you can download the materials from there. Not only did I use this to teach students how to develop algorithms, but it's a great lead-in to a text-based language. So Jeroo supports Python, Java, and C++. I'm going to use this demonstration for Python. So in Jeroo you have a text field where you can enter in your programming. You can select what language you want to use. Then you have this very simple graphical interface that basically models what you're doing as you're running your code. And so when I go and compile and run, I can run through a certain speed where it'll go through the program at a certain speed, or I can step through it line by line so that it can highlight what I'm doing. And then you've got this graphical display that'll display it all. And then when the kids get stuck on something, oh, I don't remember how to make the Jeroo move forward, you've got a help menu like Roy just talked about, the joy of help. You've got this help menu which displays a tabbed interface and gives examples of everything. So in this environment, you have a Jeroo that you're using, and I'm going to tell you the kids are going to be kind of bummed out with what a Jeroo actually is, because all it is just a little arrow on the page, and they've probably been using Snap and they've done all these great sprites and everything, and now they're like, well, this isn't very graphically exciting, and they'll start crying, and you'll just have to say, that's okay. And so I still think it highlights really well what's going on while their code is running. And so it helps them to develop thinking skills because they can write the code and then they can see the graphical interface executing the code, and it helps them with their debugging and development. So here I've got a simple program that uses the Jeroo as an object, and it uses a couple of the functions that a Jeroo can do. Jeroos can hop, so that moves them forward, and they can turn with a parameter. So in this case, I have a turn right and a turn left. And so I'm just going to tell the students, okay, I want you to path your Jeroo, and I'll pick a point on the graph somewhere. So when I'm running this as an example, as I step through the program, it's going to highlight the command that's going to be executed. And then as I go to the next step, it will perform the operation, and then it will tell me what my next operation is going to be. And I can path through the code step by step and really follow what my program is doing. See, like now I know that I'm at this step. My expectation is graphically the Jeroo will hop one more space forward, and it does. Now we're to the turn right section of the program, and it turns right. And we just step through the program, and we can graphically see our program executed. So the first task I might give my students is, I might say, path to this certain location. So I can create a lot of different tasks for my students, and so automatically they're hitting two of our learning objectives here. They're hitting develop an algorithm for implementation in a program and expressing an algorithm in a language. And here's some examples of the tabbed help menu. So I'm going to use, in this particular example, I'm going to use some Boolean methods, which if the kids don't know what they are, or if you don't know what they are, you can go to the help menu and take a look. We're going to use some conditional structure, so I'm going to use conditionals, and I'm going to use iteration in the form of a while loop, and give my students tasks within this framework. So the first thing I would give is something very simple. I would go and put a flower somewhere in the island, and this graphical representation represents an island. There's a whole metaphor that Jeroo is based on, and you can go to the web page and you can read their metaphor, but it's about this animal that lives on this island, and they eat these flowers, and there's a little storyline behind it too, so it's kind of cutesy. So I can go ahead and put a flower anywhere I want to in my island, and then I can tell the students, let's develop a program that will start at 0, 0, my starting location in the upper left-hand corner, and we'll start there, and then we'll path to where we want to go. And so they'll write a program that'll do that. My example program that I just showed you in the slide before was an example of something that pathed to a specific location. So they can write that on their own. Then we'll kind of step it up a little bit, okay? Now instead of let's go into the flower, let's create a Jeroo that's just going to bounce back and forth between the two sides of the island. Do that over and over and over again. So now we have a loop that we have to create. And we also, when we create this loop, we have some decisions do we make, okay? As I'm moving along, is it time for me to turn around yet? So here's one sample solution that I wrote. This will bounce the Jeroo back and forth between the two islands. And this is like the next level of what I would have kids do, using iteration and using conditionals in a process to solve a program. And so in this particular program, there's in the platform, there's certain things your Jeroo can do conditionally. It can decide if there's anything in front of it. So if Kim.is clear ahead means, is there anything in front of me? If there's if this is true, if it's clear in front of me, then I'm going to move forward. And after I move forward, I'm going to check and see if there's water in front of me. And if there's water in front of me, I'm going to turn around. And then I'm going to go back and check and see if it's clear ahead of me. I'm going to do that over and over and over again. So basically, you'll get your little arrow going all the way across the screen and then back. And it'll just keep bouncing back and forth until you guys press the stop and stop the program. The next stage that I do is I say, develop an algorithm that will path your Jeroo through a maze. And so we would probably start with like the center one. I think the center one's the easiest one, or maybe the one on the end's the easiest. So write an algorithm that'll path it through the maze. So now the algorithm is getting a lot more complex. But the students can play with it and see what works, and when they find things that don't work, they can change it in their program. And they're not getting frustrated like they would have in Snap, where it all has to work or it either doesn't work and it's hard to see where to debug. And then once I get them to path it through one maze, I say, now write a program that's going to be able to work for all 3 mazes. And so they're going to be testing their model and see if it works for the first one. And usually they don't really have any trouble writing for one maze, but when you start saying, now write something that'll work for all 3 mazes, now instead of testing for very specific things, you have to be a little bit more general in your algorithm and set up some conditions that'll work. And so you've got case studies. There are different cases that you can apply to your algorithm to see if it works. Finally, one of the things I can do is I can say, okay, my solution to the first one that we did was I wrote a program where in my Jeroo follows this little red path, and he goes all over the island and somehow winds up at the flower. And the kids were like, well, that's stupid. Why did you do that? Well, that was my solution. Is it correct? Yes, it's correct. Is it clear how I did that? Is the clarity of my program there? Well, I usually write it very complicated. The program's very confusing, so the kids see that it's not a program of clarity, and you can already tell it's not very efficient because he wasted a lot of runtime and a lot of movement to get there. And you can change the speed at which your program will advance, but this takes noticeably longer to run. I can make this to where it takes like a 10-minute runtime, whereas their solutions are only like 2 minutes. So you can talk about topics of efficiency, correctness, and clarity, which is another one of our learning objectives. So I really like Jeroo in that it lets me really quickly introduce a language to teach algorithmic concepts. And if the word algorithm is kind of like, whoa, we haven't talked about that yet, don't worry, Dr. Gray is going to cover that later on this week. We're going to hit on topics of algorithm. But I just wanted to show you a little tool I used in my class that made some of these concepts a little bit more simpler for my students. Thank you.